We're going to do a little bit more with inverse trig and, yeah, that's supposed to be an I. Inverse trig, day 3, and we're going to do a little bit with some trig word problems. And these are not real hard trig word problems. They're actually pretty easy. And I think you'll do pretty well with them. First thing we need to do is remind ourselves what happens with a composition of functions. This is a good review as we get closer to the end of the year and with final and all of those things coming up. If I see that f in a little circle G and then x, that means f of g of x. You plug g into f. Well, what we're going to see today is some inverse trig problems that have that situation, one plugged into another. Here's our first example. Let's say that I have the cosine of, in a bracket, arcsine of negative 3/5. Well, this is a composition of functions. I have an inner function and an outer function. And what we want to do is start inside. Okay? So in other words, just ignore what's outside for right now. Let's just pretend that the cosine that's on the outside is not there. Let's only work with the inside. So we've been doing this for a couple days. The inside says the sine of what angle theta equals negative 3/5. So our work from the last couple days has taught us that inverse sine is only defined in the first quadrant and the fourth quadrant. So I need to draw my triangle in one of those two places. Since the value of this is negative, I should draw it in which quadrant? The fourth quadrant. So I want to draw my triangle down here. And this right here is going to be my theta. That's the angle that we're working with. Now, you'll notice that I have a 3/5 here, which does not match up to our 30, 60, 90 or 45, 45, 90 triangles. So what we do is we just label it. All right? Sine is opposite over hypotenuse. So the opposite side from that angle is negative 3. The hypotenuse is 5. All right? Now, we're actually getting close to being done with this problem because now we were asked to find the cosine of this same angle. Okay? So all I need to do now is find the cosine of theta. And the cosine of theta is adjacent over hypotenuse. And I need that side, but this is actually one of those common triangles. I could either use Pythagorean theorem, or I could just recognize that this is a 3, 4, 5 triangle. All right? So we're actually done. The cosine of theta is equal to the adjacent side over the hypotenuse, 4 over 5. And that's my answer. And it is a positive 4 over 5 because both of those values were positive. So you just start inside and then work outside. All right? Let's do another one. How about the tangent of the arc cosine of 2/3? Well, we start on the inside, which is saying the cosine of theta equals 2/3. It's positive, isn't it? Which means I need to draw it in quadrant 1. So I'll draw my triangle in quadrant 1. And this angle right here is my theta, of course. And since it's cosine, it's adjacent over hypotenuse. So I'm given this 2/3, so the adjacent side is 2, the hypotenuse is 3. Now, we're ready to start moving towards the end of the problem. I'm supposed to find the tangent of that angle. So tangent of theta is opposite over adjacent. So I don't have the opposite side. So don't I need to do Pythagorean theorem? Because this is not a 3, 4, 5. So Pythagorean theorem, I would have 2 squared plus b squared equals 3 squared. And so that's going to be 4 plus b squared equals 9. B squared will equal 5 after I subtract 4. B is the square root of 5. So my opposite side is the square root of 5. I'm ready to wrap this thing up. The tangent of theta will be the opposite side, the square root of 5, over the adjacent side, 2. And there's your answer. All right? We're going to do one more of these before we look at a couple word problems. Just because people have a tendency sometimes to forget how to work with secant and cosecant. They're not any harder, they're just the reciprocal. So we see the secant of the inverse tangent of -4/5. Now, why don't we just do this now and get it out of the way? Secant is the brother to who? Cosine. So cosine is adjacent over hypotenuse. So what is secant then? Secant, you just flip it, right? Because it's the reciprocal. Secant is hypotenuse over adjacent. Very important to remember that relationship between the two. It's called the reciprocal identity, the fact that secant is the same thing as 1 over cosine. Okay, that's one of the things that we've learned. Now we're ready to go through this problem. First, I have the tangent of what angle is -4/5. So, inverse tangent is only defined in quadrants 1 and 4, and since it's negative, I need to draw it down here. Of course, theta is in its normal spot, and tangent is opposite over adjacent, so I have 4 over 5. This 5 is positive, but this 4, the opposite side, is negative. So, I need to find the hypotenuse, all right, because I'm going to need it for secant. So we'll do Pythagorean theorem. -4 squared plus 5 squared equals c squared. That's going to be 16 plus 25 equals c squared. C is going to equal the square root of 41. There's the square root of 41. So we're actually ready to finish this thing up because of this relationship right here. The secant of theta is the hypotenuse, which we found out is the square root of 41, over the adjacent side, which we said is 5. So there's your answer. Okay? All right, let's take a look at a couple word problems. So we're going to start with a pretty basic type of trig word problem. One where we're talking about a building. So we'll just draw a plain Jane building, several stories high. And let's say that the fire department has a ladder that is 110 feet long. And it's leaning against the building. Okay? And according to regulations, the steepest that ladder can be is with an angle of elevation of 72 degrees. All right? So whatever the state safety board, in Ohio it's called OSHA, they say that it cannot be any steeper than 72 degrees. All right? So the question is, how high up on the building can we rescue somebody? All right? How high up the building could we rescue someone with a 110-foot ladder and an angle of elevation of 72 degrees? Well, we're working with trigonometry, so what we need to do is think, all right, I have an angle. From that angle, I have the opposite side that I'm looking at, and I have some information about the hypotenuse. So there's one trig function that deals with the opposite side and the hypotenuse. Isn't it sine? The sine of theta equals the opposite side over the hypotenuse. Now let's fill in the information that we have. You need to start right here. You need to start by writing that down. So let's fill in what we've got. The 72 degrees is going to go right here. The sine of 72 degrees equals the opposite side is my unknown, so I'll put an x there, over the hypotenuse, which is 110. And now it's just a simple algebra problem. We are going to use our calculator, though. So if you go to your calculator, the very first thing you need to do is check which mode you're in. We are working with a degree, so I need to be in degree mode for this problem. So make sure you're in degree mode first. Okay? Now, I had to calculate the sine of 72. So I'll just do the sine of 72 and hit enter. 0.951 is the sine of 72. So now in my problem, I know that this is 0.951 equals x over 110. And then I just multiply by 110. So I'm going to multiply this side by 110, this side by 110. Use my calculator. So I will use my answer button and 110 to multiply, and I get 104.6. So x equals 104.6. What is that? That's the highest, that's this right here. 104.6 feet. I didn't write in my labels, but I stated them. You need to make sure you include your units. Okay? Let's do another problem. Let's say that you have a swimming pool. Swimming pool that has a deep end. The swimming pool is 20 feet long. The shorter side is the shallow side, I'm sorry, is 1.3 meters deep. And the deep side is 4 meters deep. This is 20 meters long. Now, let's say I wanted to know, calculate the angle of not elevation, I'm sorry, angle of depression to the deep end. Now, when we talk about an angle of elevation or an angle of depression, we always start from level. So we're going to start there, and since it is an angle of depression, we're going to swing down that way. So the angle we're looking for is right here. There's my theta. And if you'll notice, we do have a right triangle situation. I do have a side of the triangle. This is 20. And the other side right here, I have, if I do subtraction, right? It's 2.7. So looking at what I have, with trig problems, trig word problems, you need to have two of the three. What do I mean by two of the three? Well, we're going to use, in this case, since I have the opposite and adjacent side, okay, I've got the opposite and adjacent side, I'm going to use the tangent of theta equals opposite over adjacent. Now, what do I mean by two of the three? Well, there's three unknowns here. 1, 2, 3. So long as I have two of those three, then I can go ahead and solve it. And in this case, I do. I have the opposite side, which is 2.7. I have the adjacent side, which is 20. That means I can find out what theta is. Now, this is why we're tackling this today. It's a simple calculator operation from this point on. First, let's find out what this is on the calculator. 2.7 divided by 20 equals 0.135. So now I have the tangent of theta equals 0.135. Now, to find theta, we're going to use the calculator again. Now watch carefully how we do this. We are going to press second tangent, and it will show up as a tangent to the -1, which means inverse tangent. And we're doing that of 0.135. And then you press enter. And that's my answer in degrees. 7.68 degrees. No, that's a good thought to think that it is negative. But in this case, since we called it an angle of depression, we don't need to label it as negative. Okay? And we are going to stop there for today.